Good morning, everybody. My name is Zhou Wang. Today, I would like to give a presentation on my term, term project. My term project report is spam detection and characterizing on social online network. This is a this is the overview of my presentation. In the problem formulation part, I will talk about why I chose this topic as my term project and gave the motivation of research in this area. In the section, as I will summarize what other people have contributed to these related areas and the state of research in this area. In the statistical features section, I will discuss classification algorithms and techniques. I will analyze these algorithms and techniques and then evaluate and compare the performance of them. Then I will show how my program works as a J48 classifier to do spam detection. In the next section, I will discuss my research work in detail and come to some conclusions. After that, I will discuss the future work. Okay, let's move on to the problem formulation part. The increasingly popular online social networks have attracted many spammers to infiltrate users' networks of trust with a larger and larger number of spam messages. Spam is considered as a significant security issue for online network social users across the world, and spam detector is required to filter spam messages and stop spammers. Okay, let's move on to the literature review part. Some researchers have conducted an evaluation of naive Bayes classifier that was used to filter unsolicited bulk emails. The authors, at the same time, investigate the effect of attribute set size, training corpus size, limitation, and stop list on spam filters performance, issues that had not been studied. The authors came to the conclusion that additional safety nets are needed for the naive Bayes anti-spam filter to be viable in practice. Faris Aham and Muhammad Ablash presented a generic statistical approach to identify spam profiles on online social networks. The authors also used these different classification algorithms, naive Bayes, JRIP, and J48, and evaluated them on both individual and combined data sets to build the discriminative property of the identified features. The results obtained on a combined data sets had detection rate at 0.957 and false positive rate at 0.048, whereas on Facebook datasets, the DR and FPR values are 0.964 and 0.075 respectively, and that on Twitter datasets, the DR and FPR values are 0.976 and 0.075 respectively. After that, the authors analyzed the contribution of each individual features towards the detection accuracy of spam profiles. As a result, the authors came up with 7 most important discriminative features and proposed a clustering-based approach to identify spam messages on social online networks such as Facebook and Twitter. Also, Yuan Zhu and Ying Tian proposed a local concentration-based feature extraction method for anti-spam. The local concentration-based feature extraction method is considered to be effective in extracting position-correlated information from message by transforming each area of message to a corresponding LC feature. Two implementation strategies of the LC approach were presented using a fixed-length sliding window and a variable length sliding window to incorporate the LC approach into the whole process of spam filtering. A generic LC model was designed. In the LC model, two types of detector set were at first generated by using term selection method and a well-defined tendency threshold. Then a sliding model was adopted to divide the message into individual areas. After segmentation of the message, the concentration of the detector was calculated and then taken as a feature for each local area. Finally, all the features of local areas were combined as a feature vector of the message. To evaluate the proposed LC model, several experiments were conducted on 5 benchmark corpora using the cross-validation method. It was shown that the LC approach cooperated well with three-term selection method, which endowed it with flexible applicability in the real world. Compared to the global concentration-based approach and prevalent back-of-word approach, the LC approach had better performance in terms of both accuracy and measure. It was also demonstrated that the LC is robust against messages with variable message lengths. Although there are other contributions that made by the researchers and scholars in this field, and you will review it in my PPT profile. Okay, let's move on to the statistical features. Before we dive into the statistical features, let's review the motivation. In order to model a classifier to detect spam messages from the huge number of postings on online social networks, we have to select the most discriminative statistical features of online messages for each type of online social networks, such as to train the classifier. Generally, there are four basic components on social networks. They are interactions, posts or tweets, URLs, and text or messages. Okay, in my research, I have identified 9 common features which you can find on both Twitter and Facebook website. I also categorize the 9 features as into 4 fields. So, for example, for interaction-driven features, we have friends and community pages. For post-driven features, we have number of posts generated by a user, number of posts generated during a specific period of time, and number of replies of posts from other users. For URL-driven features, we have number of URLs shared by a user and the number of repeated URL shared by a user. For tag-driven features, we have number of users tagged in each post or comment and number of tagging made in a specific period of time. Okay, let's move on to the classification section. During classification, we have to make trade-off. By observation, we find that non-spam messages significantly outnumber the spam ones to such an extent that the classification accuracy is influenced greatly by misclassifying a small number of spam instances. In addition, the error for misclassifying non-spam messages as spam do not have the same impact that means classifying a spam message as non-spam. Therefore, it is reasonable to establish a cost function for classification task. We have set a zero cost to write classification, and we have set a spam message misclassified as non-spam a cost n times higher than non-spam messages. Okay, let me introduce the three most popular classifications algorithms. The first one is naive Bayes classification. In naive Bayes classification, each feature is treated independently in a simple probabilities manner. For some types of probability models, naive Bayes classifier can be trained very efficiently in a supervised learning set. For JRIP classification, which is a rule-based manner, is known as its inherent simplicity. The classification algorithm works initially by generating a set of rules for decision making and improve the rule iteratively using heuristic techniques. After training procedure, the final rule set is used as the classifier to detect spam. For J48 classification, J48, which is also named as decision tree algorithm, performs classification tasks by generating a decision tree based on the feature of the training data. Okay, here is some discussion of my research. This table compares the performance evaluation of different classifier on individual and combined data set. By analyzing the data set, naive Bayes classifier performs the best with FB data. JRIP classifier proves the best for Twitter sets, and J48 classifier shows the best result for combined data. And then let's move on to the feature evaluation using naive algorithm. This table shows that table text-driven features such as F8 and F9 are important for classification tasks for each category of dataset. URL features such as F6 and F7 are important for Twitter dataset and combined datasets. Feature F3 is important for spam detection on FB networks. Therefore, the number of posts significantly influences the decision of naive Bayes classifier. However, feature F3 does not make obvious influence to the classification task. Feature evaluation using JRIP algorithm by observation, the results are similar to those of naive Bayes classifier. The features related to URLs and tagging methods are important for classification tasks. For feature evaluation using J48 algorithm, by comparing the performance of J48 classifier with combined dataset, all the features are important to classification tasks to some extent. By observation, we find that the feature F1 do not make a significant contribution to classification task with separate FB and Twitter dataset, but it is important for combined dataset. For URL features, F9 is important for Twitter datasets and F10 is important for FB dataset. So here's the conclusion. In this paper, we have proposed a set of 9 discriminative statistical features identified from FB and Twitter datasets to identify spams on different types of social networks. We have explored the importance of each feature on detecting spam messages on different social networks, and we have quantified the importance of each feature with information gain. We have also analyzed the discriminative properties of the identified features using different classification algorithms such as naive Bayes, JRIP, and J48. According to observation, we concluded that naive Bayes classifier performs the best with FB dataset, JRIP classifier works with the best with Twitter dataset, and J48 works with the works best with the combined data set. We have evaluated the classification of each feature for different data sets. For the future work, this paper presents a generic approach to detect spam messages on social network in a statistical approach. However, context analysis of online net messages is also relied to analyze social networks. Nowadays, spammers change one or more characters of malicious words in their spam detections to fool the spam detector. However, these changes are performed in a way that humans can understand, but a normal computer program cannot. Therefore, spam detector with natural language processing is required. Thank you for all the help from Dr. Dapeng and Kai Ranshen in my study in this term. Thank you very much.